I know the afternoon is always when our energy levels dip, but I have no doubt that our next speaker will re-energize all of us. And so without any further delay, I would like to introduce Sanchit Juneja. He is the Director of Product, Big Data and Machine Learning Platform at Booking.com. He will share with us the large language model ops, LLMops, and how big orgs work with LLMs. Please join me in welcoming to the stage, Sanchit Juneja. Welcome.
Hello. Hey folks, can you hear me? Clear? Awesome. So let me start. As was given the brief, that I would be running us through what our LLMops ecosystem look like. You heard a lot about Gen AI. You heard from Microsoft. You heard from Milan from Google as well. And there was one part that he left out, which was the MLOps part. And I will deep dive into how an MLOps ecosystem is divided. Basically, a big organization like Booking.com, at any point of time you go to Booking.com, you have more than 300, 400 machine learning models. Booking.com has one of the biggest MLOps ecosystem in the world. We do around 300 billion predictions per day, so we know how to deploy ML at scale. And I would actually architecturally take you through how a typical large language model ops ecosystem look like. And the reason why I'm calling it large language model ops is how, with the advent of Gen AI, we have seen the changes in the ecosystem come into being. So cool. Firstly, let me introduce myself. I am now 17 years in the industry, so I'm quite old, and I have experience across the industry. I started my career in the US, then I worked briefly in Southeast Asia, I've worked briefly in Africa, and for the last 6 years I've been in Europe. I worked in National Instruments as well, so this is not my first trip to Armenia. So if any of you are ex-NI, let me know. You might have seen me if you were there around 15, 16 years back. Right now, I'm a director of product for big data and machine learning with Booking.com. This is me officially. Unofficially, I'm actually an ex-chess player, so if anybody wants to talk chess as well, more than happy to talk chess with you after this. Awesome. So why are we here? Firstly, to get gyan, right? No better thing to actually just impart some wisdom. Second part, celebrate being able to attend conferences again. Yeah. It's great to see people in person rather than being talking over Zoom. The in-person, non-personal thing just really doesn't work. And obviously, to discuss the typical data and ML ecosystem of a tech organization, right? So let me jump right into it. But firstly, let me clarify the terminology. I think the left part is something that Milan already covered in his presentation. So I was watching his presentation, I was staring at, oh, he's already covered this. So I don't need to take care of that, right? You know what artificial intelligence is? Basically anything that is mimicking an intelligence. In terms of the kind of terms that are very active today, what AGI is trying to do is what artificial intelligence would be. Machine learning is basically force-feeding data to a silicon-based organism that is our computer network and making it infer data. You know inferences, right? If A implies B, B implies C, the machine should be able to tell you A implies C, right? So this is what machine learning does. And deep learning is an even smaller subset, which is neural network driven. All of us have studied neural network all across the industry. The only thing that has changed recently, why Gen AI is so much into happening, is because computing power has become very cheap. If you know Moore's law, computing power doubles every X amount of years. This is actually very much true right now, right? This is a funny image, but you might have heard a lot of terms like FMOps and LLMops. A lot of big tech companies are talking a lot on this right now. So let me first define what MLOps is, right? I think most of you are developers, right? If something becomes complicated enough, developers like to put an ops layer on top of it, right? When development became complicated enough, you had DevOps. When security became complicated enough, you have SecOps. Basically, an ops layer is abstraction of the tooling layer that makes the horizontal process happen. Similarly, machine learning has become so complicated, so widespread, especially in big tech. As I'm saying, right, we do around 400 plus models of Booking.com. At any point of time, if you're looking at a Booking.com website, you're interacting with a machine learning model. How you see the ranking of the hotels that you see is determined on your personal preferences. So there's a lot of machine learning interaction, at least what big tech does, right? Which is now abstracted into machine learning operations. Your typical model training and model turn serving has been horizontalized into a MLOps layer. So if you are DevOps, you talk in terms of CI/CD, continuous integration, continuous development. If you are MLOps, you talk in terms of CT, continuous training, right? And now, what is FMOps and what is LLMops? So now you see a lot of foundational models that Milan covered, models from Falcon, from Stability AI, from Amazon, etc., etc. All of those models, if you put a foundational model ops layer on top of them, it includes image generation, content generation, etc., etc. It is FMOps. But if you are only talking about a narrow subset of language generation, it is LLMops. So FMOps is a superset, LLMops is a subset. Cool? Awesome. So now I will take you through typical 2 things that you do if you are in machine learning. If you are, let's say, have worked on an MLOps ecosystem, or if you have ever developed an MLOps ecosystem, you train a model and you serve a model. And your typical application design is divided into 2 parts. You have the applicative ML layer, where your chatbots, where your content generation, image generation, all the things that Milan mentioned in his last PPT reside. Basically, your code generation, etc., they reside there. And this is your typical MLOps ecosystem or model ops ecosystem. You can call them interchangeably. There is an interconnection to the data ecosystem, which is basically if you are training a model, you are actually feeding it a lot of data, right? And there are a lot of nuances to it, especially if you are a big tech org like Booking.com, you have a typical data lake or a data mesh architecture, where all the data that you have generated in your organization is stored in one place. So Booking has one of the biggest data lakes. It's around 1 exabytes in size. And if you want to discuss this, I can discuss this with you offline as well, right? This is how a typical ecosystem looks like. Don't worry about it. I will dive deeper into each of them. And if you are on the model serving side, once you have trained the model, you actually want to put it in production. And this is how it works like. Then let's say you have the app or the web facing, your application, which is your chatbot, etc., and this is your typical model ops layer, right? Don't worry about each of the steps, which is model training, serving. I will pick each of them in one particular slide. I will tell you how it is done today and what has changed with Gen AI into the ecosystem. And this is what has happened with LLMs. Now, a big organization like Booking.com, we not only deal with SOTA ML models, which are transformer-based models, which Milan described, right? We deal with a lot of models. So when we create an MLOps ecosystem, we have to make sure that our ecosystem scales for our existing models as well as for large language models. So this is how the ecosystem has changed. We are envisaging something called a wrapper, because you saw Google, right? Google has something like Vertex AI. There are other vendors like AWS Bedrock. There is Meta has Llama open source, and if you have LangChain, etc., etc. So we allow an enterprise middleware that will allow third-party model hits if you're just calling a model as a service, right? We also allow a prompt engineering optimization, which I think would be covered in the next PPT as well. Basically, if you are just calling a third-party model without actually optimization, how do you make sure you get the best output from the model? Because as you might have heard, or if you have used the model, models hallucinate a lot, right? So how do you control the output of the model to make sure your business product output is not determined, right? And finally, you have something called embedding management, which again Milan covered and Microsoft Chinmay also covered, which is basically if you want to give a memory to a local large language model, you can have a vector database deployed in closed loop. So I will cover this as well, don't worry. Cool. And similarly, on the model serving side, the ecosystem remains the same, but these 3 new areas are something that come out. Cool. As I discussed, right, now what I will do is, I will dive deeper into each layer. I will tell you the complexity of the layer before large language models, and now what has happened after large language models, and opportunities, at least what I see from product lens, what Booking sees, et cetera, in incorporating these flows into our ecosystem. Yeah, so let's first dive into data layer, right? Data is the bedrock of any machine learning model. I think you must have read a lot of these articles. Your machine learning ecosystem, your large language model ecosystem is only as good as your data ecosystem, right? And so bedrock of any ML ecosystem, and this is because it's your training data, right? Before LLMs, there was already a lot of investment into this area, right? Because big data has been a part of our ecosystem for a very long time. It's just that now we are realizing that there is actually monetizable value in big data, right? So if you know terms like data lake, data mesh, there was already a lot of investment in this area, right? But as you remember, Milan covered, in a typical non-large language model ecosystem, most of the data that you ingest and most of the ML ecosystem that you build is structured data, right? What do I mean by structured data? Your data is in a predefined format. It's into Parquet format or Avro format, et cetera, right? But now what has happened is, with the advent of LLMs, you are discussing the ecosystem where most of your use cases would be a chatbot, direct user interaction fed into your backend, or maybe let's say generation on demand, text summarization. So there is a lot of unstructured and semi-structured data that has come into the ecosystem. So there is a new paradigm that we are at least seeing in data lake, right? If you know a typical data lake has ingestion pattern like streaming, batch ingestion, and CDC, et cetera. But now we are envisaging the need of something called real-time ingestion. Because if you are serving a chatbot kind of a use case, the user is not going to wait for 1 minute for you to reply, right? It has to be near real time. So there's a new advent. There are tools out there, open source tools. I don't know whether you've heard of Llama Index, but Llama Index is a tool which specializes in this. Your ingested unstructured data made ready for your data ecosystem. So there's a lot of investment in this area already. Next one. What is model building, model training? Basically, if you are a MLOps ecosystem, in the first aspect that we covered, you build a model, right? You prepare a model, you train the model through data, you check whether the output is within the given governed parameters or not before actually deploying it to the ecosystem. So this layer is your interface with the data ecosystem. So it's a very important layer. A lot of VC investment has always targeted this area. Like in a typical non-LLM world, this layer was just a middleware, right? You were building a data model and just deploying it. It was like a factory line, factory production line, right? But what has changed with LLM? A lot of organizations are not going to build their own LLMs, right? Even big organizations like Booking.com are thinking whether we should build our own LLMs or not, et cetera, right? But what you can do is, you can solve a lot of use cases directly calling a third-party LLM. And this is where in a LLM ecosystem, we are envisaging that the model serving, the model building layer of a MLOps ecosystem would evolve into a middleware layer, where what we will do is, we will provide a proper enterprise middleware. Something like you have Stripe. Stripe is for payments, right? It's a payment layer. You can pay via bank, you can pay via WhatsApp, et cetera. Similarly, a big organization like Booking.com foresees that we can evolve the ecosystem, that we build a middleware where we can try to serve by a different model, but we can fine-tune by a different model. So let's say we are working with AWS Bedrock. We can make sure that if there is a use case that only requires text summarization, which is a low-hanging fruit kind of a use case, we can use the enterprise API call. We can just directly call AWS Bedrock or Google Vertex AI or NVIDIA AI Foundations. There are so many vendors out there, right? But if we want to fine-tune a model, we can fine-tune it in-house. Or we can even fine-tune it using these vendors as well. So this becomes a typical complicated monolithic kind of a ecosystem. Cool. Let's come to model serving. Model serving is actually deployment of the model. And this has a hardware extension to it. This layer is highly extensible, requires scale-up engineering. As I was telling about Booking.com, we do 200 billion predictions per day at 4 nines, 99.99% uptime. So we have some experience deploying high scalable applications. A lot of VC investments has already gone. I don't know whether you saw NVIDIA's latest release, but I think they are one of the most profitable companies out there. They did 16 billion of revenue in 1 quarter. So there's so much demand for GPUs. If you have worked on GPUs, etc., right? In a typical non-LLM world, even in big organizations like Facebook and Google, etc., most of our use cases used to suffice in 1 GPU. 1 GPU is big enough for us. Whether it is A100 or let's say the latest one is H100. So one of the best GPUs out there. But if you're talking about, let's say, 100 billion parameters, 200 billion parameters, it cannot be via 1 GPU. So if you are, and this is the change that we are envisaging in a, let's say, non-big LLM world, that we will have to start thinking about distributed GPU training. That 1 GPU cannot be enough. We have to start thinking about 1 GPU deployed in 1 data center, another GPU deployed in another data center, and how we make sure that we can sync between these 2 GPUs. So this is one ecosystem. If you are, let's say, getting into big models, is specifically what we are looking at. Another part is, you've already seen NVIDIA has GPUs. But if you know, Amazon is coming up with their own hardware. There is Inferentia and Trainium, etc. There are organizations coming up with their own XPUs, etc. So a lot of investment is going into hardware as well, because hardware is a limiting factor right now. Let's come to the next part, which is the feature engineering part. And this is a very typical ecosystem part of a large language model ecosystem. This was touched upon by Chinmay in Microsoft as well, because what you want to do is, in an MLOps ecosystem, you want to create these pre-computed features, because you want to reduce the latency of the output of the user as much as possible, right? And if you look at an MLOps ecosystem, a lot of vendors out there, a lot of big companies out there, what they realize is that creating a marketplace of features, which is called a feature store, is very much valuable. And this is what, in a non-LLM world, in Booking.com, we already do right now. So we have a feature store where our scalar as well as vector features are actually already stored. And we use them for both online and offline serving. Online serving is real-time serving, and offline serving is batch computed, offline serving, right? Most of the use cases in a non-LLM world used to be scalar, but with the advent of LLMs, we are realizing that real-time serving is very important. We're also realizing that vector stores are very important, which was already discussed, right? We are realizing that nearest neighbor search is very important. One thing that a lot of people are realizing is, just like a feature store as a vector store, a lot of people are also thinking about something called a prompt store, because this is one aspect of prompt engineering that is very new. I think Facebook deployed something on this last week, because if you are just doing prompt engineering on top of a publicly available large language model, your latencies are very high. Even if, let's say, you have an enterprise contract with OpenAI, etc., you typically get latencies between 20 seconds, 30 seconds between replies. So what you can do is, just like for features, you can have ready-made prompts, store the output of those prompts in a nearby MySQL or PostgreSQL database, and use that prompt store to reply coherently. This is an output. If you have ever built a chat application in your life, caching is a very easy example. People cache data all the time, right? But people are bringing prompt store caching into large language model deployments as well. So this is a new thing. And yes, let's go to the next part, which is the ML governance part. One aspect of the MLOps ecosystem is, as and when AI is growing by leaps and bounds, a lot of governance on ML and AI is coming on in the ecosystem. So if you have developed a tooling, any kind of ML tooling which is deployed, you will have experience, let's say, I don't know whether the government of Armenia, but especially in the EU, there is wide-ranging regulations on AI. There's EU AI Act, there is e-privacy law that is coming. There's a law called DAC7, which is basically how your data is processed. There's a new law which came called DSA DMA, basically how you cannot actually personalize the data for somebody which is not part of your core business proposition. So there's a lot of governance on top of AI which is coming as and when AI is gaining adoption. In a non-LLM ecosystem, governance always used to be a problem for us, especially if you're operating in a European context. But even without European context, you have international regulations. There is something called PIPL in India and China. The US is coming up with their AI Act. So this has always been an issue. Especially with the advent of LLMs, a lot of people are realizing now that you're dealing with such big models, you have to think about proper ML registry. Your models should be registered. So let's say in the future, if the government wants to see what models are you are using on your website, you can easily expose it to them. The government wants to see, okay, whether you are providing unnecessary bias in those models, etc. or not, especially if you are operating in a sensitive area, let's say e-commerce or something. But there are other parts of ML governance as well that we are thinking about. So there is a concept of data drift. So if you have ever worked, just like we were discussing microservices in the last presentation, right? You have a concept of configuration drift and deployment drift. Similarly, in MLOps, you have a concept of data drift and model drift. So there's a lot of investment that goes into this area, especially in MLOps, how to manage data and model deployment drift. And yes, ML observability layer. So as and when data and ML is becoming big enough, special tools are coming out which handle observability of those tools. I hope you know what is different between observability and monitoring, right? So this is a touch point interaction. You have heard New Relic, etc., which are system observability tools, but there is a new advent of tools such as Monte Carlo, which do data observability. If you have a big enough data lake, you need to have data observability tooling attached in, right? Similarly, in ML, there are tools like Aporia, Arise, Labs that have actually come out that do ML observability. Basically, they check, okay, whether ML output from one point to another is well lineage. The lineage of your ML output is maintained. And especially if you are, let's say, in a financially sensitive information, if you have compliance regulation like SOX, where you are reporting your data to public markets, you have to make sure that whatever data you're reporting is actually traceable. That's why compliance is very important. This was always an important area, even in non-LLM world, but especially with LLMs, a lot of hallucinations have come into the picture. So there are tools like Arise, which allow you to actually moderate the output of your LLM. So let's say they can actually limit the kind of input your LLM can take. They can actually break the chain of thought if the LLM is actually going into a wrong direction. So there are dedicated tools out there. A lot of people can build these tools in-house as well, but there's a lot of investment going here as well. There is a publicly available library called guardrails.ai, which is also doing something similar. So just in case you want to see something open source, guardrails.ai is also available on Git. And we come to ML experimentation. Just like any tooling, experimentation is a key to improving upon the product output. A/B testing, split testing. Most of you are working in publicly facing products, right? You would know what split testing is, right? But in machine learning, split testing can be a bit complicated. So there's concepts such as called MAS, multivariate testing, where you can actually deploy multivariates into the ecosystem. There's also something called interleaving. These are research terms, where basically you can deploy multiple hypotheses in the same ML ecosystem. So there's a lot of investment. A typical MLOps ecosystem like Booking and other tooling also do that. There are also publicly available tools like Weights and Biases who do it out of the box as well. So there was always an investment here. But because of the LLMs, this area has really gained prompts. So now a lot of people are doing prompt engineering experimentation. If I say A plus B is equal to C, would it result in the same output as B plus A is equal to C? You can actually try it out. So there's a very good research paper on chain of thought prompt engineering, which actually tell you in a GPT-4, it is so non-deterministic that you can ask it a simple arithmetic question and 7 times out of 10 it will get it wrong. So it's very important. This area is highly important, especially if you are looking to deploy production applications. And there was a last part which was kind of ignored, but I wanted to make sure that this was also carved out, which is called the feedback loop. After all the MLOps ecosystem is done, there's a feedback loop component attached to your application as well as your data ecosystem, right? In a typical non-LM ecosystem, a lot of people used to use feedback loops, but they used to use it for innocuous reasons. We used to do label collection. We used to do basic prompt mechanisms, etc., etc. But this area has gained a lot of attraction in the new ecosystem. So if you're discussing reinforcement learning, RLHF, etc., etc., this area has gained a lot of investments in the area right now. Anybody who is chasing AGI, let's say Google DeepMind or OpenAI, everybody is trying to optimize on agents. Anybody who's trying to create agent kind of product flows where you don't need to prompt, the LLM can prompt itself, is working on the feedback loop component. So there's a lot of investment Booking has done on this area as well. A lot of investment other tech companies have done as well. But this can also be done out of the box. So every box that I'm showing you right now, whilst you can build it in-house, there are publicly available tools out there, even open tools, LangChain, etc., which will allow you to do this end-to-end. And yes, we come to what you can finally do with LLMs. So if you are looking for a production organization, there are broadly 3 things you can do with LLMs. You can either just optimize on prompt engineering, and if I tie it down to the use cases Milan showed, if you just want to do content generation, text summarization, etc., you just need to call a publicly available API. You can either call it via LangChain, because LangChain has a lot of open models, Falcon 9, etc., or you can go via enterprise API, which is AWS Bedrock, Google Vertex, etc. But it is a basic API call. It's just like you have another enterprise API. You have a lot of vendors you work with, right? You work with MailChimp, etc. So they become just another API to call to. There's another component which is embedding management. So basically what you can do is, if you have problems with hallucination and you want to provide the local context of the model to your organization, to your LLM call, you can deploy a local vector database in the closed loop so that you can actually give a nearest neighbor memory to your database. So this is a lot of people, a lot of mid-scale organizations are trying to do this because the last one is quite costly, the first one is not production ready. But you can make the first one with vector databases to actually deploy a production ready application. A lot of people who are actually doing chatbot kind of things are actually doing this. Because let's say if you are talking to a Booking chatbot, Booking launched a chatbot, right? You can ask the chatbot anything, any random crap, right? How do you make sure that the chatbot replies with the right context? It is done with an embedding database backend. And finally, and the most ambitious one, you can actually fine-tune. Fine-tuning is actually changing the weights of the database. A 65 billion parameters LLM, you can actually train it in-house, go it through your localized data, so you can change the database weights of this. So you can hyper-optimize this large language model to your particular application. According to me, this is where the industry is going. A lot of small large language models deployed and a big orchestrator deployed on top of it. Orchestrator was covered in the last presentation, right? And this may be the future, but not every organization is willing to do it right now because it is very capital intensive, etc., right? But the costs are coming down every day. When I started out, OpenAI was giving fine-tuning at 10x the price of actually model serving. 1 week back, OpenAI GPT 3.5 allows fine-tuning at 2x the cost of serving. Google allows fine-tuning at the same cost of serving. So the cost is coming day by day. So this is an area which is going to revolutionize the industry, and this is where a lot of investment from agents, etc., is coming on. And one thing I definitely want to call out, they are not mutually exclusive. It's not that you can do one and the other. You can obviously do prompt engineering on top of vector database. You can use a vector database with a fine-tuned model. So nothing is stopping you from doing that. But these are the 3 broad areas you can use LLMs for. And this is it. This is me. I hope I didn't bore you enough, yeah? And hope it was valuable. Yeah. Awesome. Thank you so much.
Thank you very much, Sanchit. Very, very interesting to get such an in-depth look at the LLMs. All right, let's move on to our question and answer. It is a joy to also announce that we are ahead of schedule, which is a true rarity in conferences of this scale. So I'll give everybody a moment to submit your questions for Sanchit, and we'll have a few more minutes on stage with Sanchit. Thank you for being here. All right, first question. Do you work on development of your own LLMs, or do you use an existing model? What models do you use and why? And what about vector database?
Sorry, I couldn't hear you.
Yeah, of course, it's not audible from here. Please take a look.
Actually, I have a A100 at home, so I still code. I don't develop LLMs on my own. A, I don't have a PhD. B, I don't have the technical expertise behind it. I typically use open large language models. So if you go to Hugging Face, there are models like Falcon 9, etc., etc. You can deploy them in your local database. You can actually deploy your large language model in your CPU as well. Nothing is stopping you if you don't have a GPU to actually deploying large language model. It will be just slow, right? But you can play it out. And if you look at the no-code tools out there, you don't even need to know coding to actually do large language model fine-tuning. I haven't coded for the last 10 years. I was a software engineer, but I hadn't coded. But you use no-code tools, you can actually fine-tune on your own. Nothing. The development as a barrier is so far removed right now, it's no longer an issue. Yeah. Okay.
Question as you wish.
Does Booking use OpenAI at all? We do. Yeah. If you look at the AI trip planner that Booking launched last month, it is deployed for all US customers. We use OpenAI, but it's very important. We actually have 300 models in-house. So recommendation, etc., were actually chained. So we use something called model chaining, which is a very important aspect of LangChain. We took the output of one model, use it as the input of another model, output of that into input of the another, and finally the content generation was done by OpenAI, GPT-3. Yeah.
Maybe 2 more questions, I think, will be perfect.
Sure. What do you think AI will change in 5 years? I think everything. Our jobs, I don't know, maybe, right? But one thing is for sure, a lot of things that we took for granted. I can give you my personal experience, right? I hadn't coded for the last 10 years, right? I used to be a prolific coder, but I stopped, right? But then I took up, let's say, something like a code interpreter or something like Amazon's Code Whisperer, and you can actually code again. And it's very highly optimized code. It's not, let's say, ON square dependency, etc., etc. It's very optimized code. So I think a lot of issues, a lot of barriers that we had, that for launching a tech organization or a tech product, you needed to necessarily be tech background, that would be definitely removed. If you're tech aligned, if you've ever coded, if you know the nuance of tech, industry will change. I think I read a Times article which said the first manufacturing unicorn, a billion-dollar organization, took 1,000 people. The first e-commerce unicorn took 1,000 people. The first SaaS unicorn took 200 people. And the first AI unicorn in the next 5 years would only take 3 people. So it's ridiculously abstracted. Yeah.
Thank you so much, Sanchit. I think that's all the time we have for the
Yeah.
Q&A. Thank you for being on the stage and sharing all your expertise. Please join me in thank you, Sanchit Juneja.